So now we're going to start exploring quadratic trig equations, which is kind of a crazy idea to think about. We're going to do this in two parts. In the first video, we're going to be looking at some basic ones, and I say basic in the sense that there's really only one trig argument. So it might just be a cosine squared or a sine squared or a secant squared or something of that nature. In the next video, we're going to look at ones with multiple trig arguments and use a process called factoring. And use the zero product property and all that stuff that we've done with quadratic equations. So let's start off with a basic one. Let's say we've got the tangent squared of x minus 1 equals 0. Now there are a couple of approaches we could take. We could go through a process of factoring. We can totally do that. But when I see only one trig argument, what I'm going to try and do is I'm going to try and reverse operations, just like we did when it was linear. But it's going to be a little bit more complicated because our answers are going to multiply a little bit. So what we're going to do first is start trying to get tangent by itself. Now keep in mind that this tangent squared is really the tangent of x, the quantity, squared. So the first thing I'm going to do is bring that 1 over to the other side. And what's next is trying to get rid of that squared. Now if you just take the square root, you've missed a solution. What we actually need is with the tangent of x to equal the plus or minus square root of 1. So actually that would just become 1. So again, I took the plus or minus square root to get my solution. So now I want to know where tangent is equal to either positive 1 or negative 1. And good news is it's in every single quadrant. Pi over 4, 3 pi over 4, 5 pi over 4, all my pi over 4s, and 7 pi over 4. Now if I were to factor this, I would have the tangent of x minus 1 and the tangent of x plus 1 equals 0, set those equal to 0 and solve, and I'd end up with the same solution. So my process is not really going to change. So how about this? How about we had like the 2 sine squared of x minus 1 equals 0. Our process is going to be just like we did with the tangent, but a little bit more involved. We're going to have the sine squared of x is equal to 1/2. So when I take the plus or minus square root of both sides, I'm going to have the sine of x equals plus or minus the square root of 1/2, which means the sine of x is equal to plus or minus 1 over the square root of 2. Sine of x equals plus or minus, let's rationalize it, square root of 2 over 2. Turns out that my answers to this equation are going to be exactly the same as the previous one. I'm going to look at the pi over 4s because that's where I have square root of 2 over 2, and it ends up being all of them. So my solution is exactly the same as the one I just did for tangent. All right, what about one like this? We're going to have 2 secant squared of x minus 8 equals 0. So I'm going to solve this like we did the previous ones. I'm going to bring the 8 over and divide by 2. Secant squared of x is going to be 8 over 2, which is going to be 4. So I'm at a point now where I can take the square root of both sides, plus or minus square root of both sides, and I'm going to have secant of x is equal to plus or minus 2. Again, I can think of it really as the cosine of x equals plus or minus 1/2. So I'm looking for where the cosine is equal to 1/2 or negative 1/2. And that's going to be at all my pi over 3 angles. So my solution to this one would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. How about one where we've got cosines? Let's look at cosines. Let's take a cosine. Let's make that a 5. Minus 5 equals 0. Let's see what we can do with that one. So again, my process is going to be the same as we did with the others. I'm going to bring everything over to one side. And I'll have 5 over 5, which I know that is 1. And so then I can solve that. Cosine would equal plus or minus 1. Now, that means that I'm going to be here and here, so on the x-axis. I'm solving from 0 to 2 pi, not including 2 pi. So my solutions to that would be 0 and pi. How about a cosecant? Let's try that one. So in this one, what we're going to do is bring our 2 and our 4 over, giving me cosine, ooh, not CCC, CSC. And it's going to end up equaling 1/2. So I'm going to go through the process like we did before. I'm going to have plus or minus 1 over the square root of 2, which means the cosine or cosecant of x is plus or minus the square root of 2 over 2. Actually, I'm going to stop it right there. I'm going to start at this place and take the reciprocal. So I'm looking for where the sine of x equals plus or minus the square root of 2. Now, I have a problem here because the sine can never be greater than 1 or less than negative 1. So we have a place here where square root of 2 is like 1.4. So I have an equation here that actually doesn't work. It has no solution. So that is going to happen periodically when you have quadratics. You'll get equations that appear to work, but then end up don't working.